Hello everyone. Today we are going to study about the second chapter, you can say, in the introduction unit, and the chapter is going to talk about image sampling and quantization, spatial resolution, intensity resolution, and we are also going to talk about relationship between pixels, neighborhood, adjacency, and connectivity, path, region, boundary. So everything we are going to see in today's class. So starting with, we have sampling on the top. So what is sampling? So sampling basically divides an image into smaller dots called pixels. So you can see that more number of pixels are present, we have more amount of clarity. So let's see what is sampling basically. If more pixels are present in an image, so you can say that 5 megapixel is better than 2 megapixel. Why we say? Because in that more details are present, more points are available, and because of those points you are getting better clarity. Okay, so those pixels arrangements are actually explained by sampling. So you can have a look on this high spatial resolution image, this one, then the medium spatial resolution and the low spatial resolution. So from these three, what you see that if the resolution is less, your quality of image is going to be less because you have lesser details to see onto. Okay, so you can say, in other words, you can say that low resolution means fewer pixels, and fewer pixels means image looks blurry or it's not clear to our eyes. High resolution means what? How it has more number of pixels, and because of that, image looks sharp and clear. The clarity increases, which is available here in high resolution spatial image, and there is low spatial resolution. So this is actually coming here. So more pixel equal to higher spatial resolution, and higher spatial resolution is equal to better image detail. So you can see in these two images, these pixels are actually given some numbers. Okay, so if you have those informations from this image, what you are able to identify that since we have very less number of pixels, so because of that the clarity is not there. Okay, and for each image some intensity values will be there that will be seeing in the next resolution part. But here you can see, to have a meaningful understanding of the image, you should have more number of pixels. So I can say here this image is not clear to you because pixels are less. When the pixels are increasing, you will be able to correctly see this image. Okay, same goes here. You can see only 4 pixels, then some 20 pixels, then 40 pixels. So from only 4 pixels, you cannot recognize whether that is a square or that is a circle or what. But when the number of pixels increase, you can easily understand that what shape it's trying to draw. Okay, so image sampling is the process of converting a continuous image into a discrete set of pixels, where each pixel is represented by an intensity value. Okay, so this intensity value you can see here. The lower the darker value basically represents lower, and whiter part will be representing your the higher value. So this is the original image, and here is the sampling factor of 2. Sampling factor of 2 basically means, you take one pixel, leave the second pixel, then again take the third pixel, then leave the fourth pixel, then again take the fifth one, then again leave the next one. So one you take, one you leave. Okay, so to our eyes in this image you can say, we'll consider this 157, we'll not consider this 153, then again we'll consider 174, then again we'll not consider 168, then again we'll consider 150. So our image will be 157, 174, 150, 129. So in bigger images where so many pixels are available, to our eyes it's not going to make much difference. Okay, but if we keep on doing the higher sampling values, for example factor 8, so what happens? It will consider 1 pixel, it will leave 7 pixels, then again it will take 8 pixels, then again it will leave 7 pixels, then again it will take right. So one you are taking, 7 leaving, one you are taking, 7 you are leaving. So because of this, what will happen? Ultimately the quality of image will be degrading. Okay, and here you can see that this is factor 16. So one you are taking and 15 you are leaving, then again you are taking the 17th one, and again 15 you are leaving. So by this the quality will decrease. Okay, but there is one benefit of sampling also. For example, original one image and sampling factor image 2, you are not able to find much difference, but the size of this image is lesser because the pixels are half. That is the way of reducing the size of the image also, you can say. But at the same time, the quality will also decrease. So the same thing is explained here. If you are taking the sampling factor of 2, 50% of the pixels will be available. Okay. So what happens? What is the meaning of sampling with factor 1, factor 3 that is mentioned here? So you can see that what effect it will give to the image, that is mentioned here in this part. Okay, so to make the understanding much clearer, I have a coding part also. So let me run the code and we'll see how the code basically performs. So you can see this is the image you are seeing. This is sampling factor 8. So let's decrease the sampling factor. Uh, Let me give it this time, instead of 8 we'll be giving 3. Okay, so one pixel it will take and 3 it will leave. So you can see what effect it gives to the image. So you can see that here this became little clearer because the previous image was about sampling factor 8. This time we'll take sampling factor 8 and then we'll see what difference comes. You can see here the image will appear. You can see the image quality reduced. Okay, we'll go this time with 16 and see that how the quality of image decreases when we increase the sampling factor. So lesser number of pixels will be available, you see. So if you give 32 or 64, in that case what will happen? Barely you can recognize that is the same image which we were trying to give the input image. Now we'll be going for quantization. So you understood about sampling. Okay. So we have next is quantization. So quantization is nothing but quantization basically converts the brightness into fixed values. Each pixel gets a number to represent brightness. Okay. So for example, as you saw in the previous case where the image was there and some numbers were given. Okay. So the number was like you were getting 255, 252, 300, 200. So what are those number basically means? Those are the intensity level. Okay. The lower the value, it's going towards the black. Higher the value, it's going towards the white. Okay. So let's see. So this is, you can say this is low quantization. Half part of this image is low quantization and half part of the image is high quantization. Okay. So 4 level and here 256 level. So in simple words, you can say that you have only only 4 possibilities are there. Okay. So you have given 4 shades only to draw this image. Okay. So why we are not considering this white part? Because this will be always available. Okay. So this 4 level: dark, very dark, then light dark, then lighter dark, and lightest dark. So from these 4 parts only, you have to create the complete image. So you have, your scope is reduced. So because of that, the image quality is not that good. But here you have 256 levels to draw this image. Okay, whatever you want. Like you can do the dark setting, you can do the light setting, or you can do whatever type of setting. Everything is possible. So here the quantization level is high, so clarity of the image is also very high. So quantization basically converts pixel intensity values into a limited set of gray levels. So that is the thing. So if you have quantization is high, you have a better level of grays to represent the image into. So see the levels. So 16 levels means it's coming here. You can see that 16 levels we have. Here 32 levels we have. Here 256 levels we have. So what basically happens when the level increases is actually available in this GIF. You can see that 2, it starts basically from 2, then 4, then 8, then 16, then 256. So you can see that if you have to show a shadow, okay, so that shading is very clear when the quantization level increases. So by this we want to say that quantization basically increases the quality of your image in terms of detailing. Okay, so have a look on this. This is quantization level 4, this is quantization level 16, and this is quantization level 256. So let's see the code again. So you remember the code which we were running, in this there is a quantization level also. So this image is actually 256 quantization level. Okay, so this time we'll try to change this 256 to only 2. Okay, and we'll try to run this. So we'll see this. So two quantization level means what? Only white or black you have to represent. Okay. So you can say that quantization level 2 is actually black and white image. So these are different quantization levels. Okay. So what you understood from sampling and quantization? So sampling is nothing but from lesser number of drawing. Like for example, if a kid is there and kid got a pen, okay, and I am telling that kid to draw some image, okay. So what the kid will do? The kid will try to a small kid of 2 years, 3 years, 4 years, 5 years, maybe trying to do a rough image, okay, maybe a circle, a square, or something. And because from very less number of lines that kid is trying to portray something, but when it comes to a person who is very well versed in painting, what they will do, from the same pen, from different setting, the person can draw something very nice, like a bottle, like a tree or something. So this is actually the example of sampling. You have more pixels to represent your ideas. Then what is quantization? Now in the same case, the person who knows painting very well, if I'm giving only two sketch pens, black and gray, so what the person will be able to draw? The person will be able to draw something that will be clear, but only two possibilities are there. Gray and black only the person has to draw. Okay, so the person will not, the image may not be looking very detailed. But if the same person has 256 colors, 256 shades of black and white, okay, so what the person will be able to do? Very detailed image. So this is nothing but this is quantization. Okay, and how many pens the person can use, that is your quantization level. So in the common definition you can say, so what happens here, we have the white area. Okay, so this white area is present. So because of the white area, the higher values are present, the intensity value is high. But here suddenly from white part it dropped into black part, and because of that the intensity value suddenly dropped. Now again slowly you can see this part is little lighter compared to the corner part, so the intensity here will increase. So that is only happening here. Okay, then again it's moving towards the darker area, so again the intensity is dropping, and suddenly it entered into white area. Because of the white area, what happens? Suddenly the intensity value increased to the maximum. Okay, so this graph comes from this image. Okay, now these values are actually sampled here on different pixel levels, and you can see that these values will be here. How many quantization levels are there? So it moved from different shades. So very dark is represented here till it goes to the whiter part, that is represented here. So everything lies in between, so that is here. This is quantization, and this is your sampling, the plotting of graph based on pixels intensity values. Now here this is nothing but that pointing those values, okay, and recreating that one. So from here what it identified, it stored the values. Okay, so now you can see this corner, this part of the pixel is actually colored. So because of that it will be like, it will be considered 0. But here in this pixel you can see that maximum part is covered, so because of that this will be considered 1. So we have to make this the equal representation coming from quantization value, and you are able to see this digital copy of your input, whatever input you give. And like this is the basic working principle of all the digital cameras. Okay, so it goes like this. So digitizing the coordinate value is called sampling. Yes, because whatever the coordinate value is coming in x and y, that digitization is sampling, and digitizing the amplitude value is actually quantization. Okay, so this is sampling and this is your quantization. Coming to the resolution, high resolution camera can give you higher quality of image, and low resolution camera can give you lower quality of images. So why it basically happens, that we'll see here. So the first one is spatial resolution. That spatial resolution you can understand like it's very similar to sampling. In this you are having pixel counts, total number of pixels in an image. Like for example 3000 into 2000 pixels. Okay, that will be in megapixels. Then physical size. So three basic things are there. Pixel counts. So more pixels, more clarity. Physical counts, the actual display or print size of the image. Okay, if the image is 10 inch by 12 inch, so like this we represent the quality of image based on pixel count we represent, and based on resolution. Okay, pixel per inches, in 1 inch how many pixels are present. Okay, So that is also, you can see, or we also say DPI, dots per inches, that is pixel per inch only. So here again the same image comes. If you have higher pixel values, you are able to see the clarity of image in a better way. So spatial resolution is an image of an image basically depends on how sampling is performed. That is how many pixels are used to perform the image. Okay, higher pixel value, higher spatial resolution. Okay, so better sampling is done. So that relation only I have mentioned here. Higher sampling results in higher spatial resolution and finer image details. You can see one example that I have taken from Gonzalez and Woods book. So you can see that the first one is 930 dpi, 930 dots per inches. Here we have 300 dots per inches, 150 and 72 dots per inches. So lesser dots, lesser pixels per inches will give you lesser quality. Higher pixels per inches will give you higher quality. That is the main logic. So you can see the quality is decreasing, visible quality is decreasing. Okay, now comes intensity resolution. You saw spatial resolution, now this is intensity resolution. So intensity resolution is very similar to what you saw, that you quantization levels you saw, no, that is based on that only. So you can see here intensity resolution refers to the ability of an image to represent different level of brightness or gray levels. It determined by how finely the intensity values are quantized during image digitization. Okay, so for 1 bit image that is only 2 values, for 2 bit image only 4 values, for 3 bit values only 8 images. So basically that is 2 to the power you can say bit. Okay, so 2 to the power 1 will be 2, 2 to the power 2 will be 4, 2 to the power 3 will be 8, so 2 to the power 4 will be 16. So basically you are getting that many pens to draw the diagram. So you have only 2 colors pens. Here you have only 4 colors pens. You have only 8 colors pens. Here only 16 color pens. And here 256 colored pens you are getting to draw an image. So definitely from this you will be able to draw the image much clarity. So that is your intensity resolution. Okay. So relation between bit depth and intensity level will be seeing. So you see that 1 bit image will be giving you only two images, two part of, so two values only will be coming, black or white. If for 2 bit image you have little higher values, for 4 bit image you have even more high, even higher than that. So you can see that intensity levels are 2, intensity levels are 4. The same thing what is represented here, that is same I have given you in the tabular column. So here you can see that when the number of intensity level increases, the clarity of the image also increases really well. So high intensity level equal to smoother image appearances. So intensity resolution, this also I have taken the example as from Gonzalez and Woods book. You can see that this is your 774 into 640, and you can see that from B to D is actually displayed at 128, 64 and 32. So this is 128 intensity level, 64 intensity level and 32 intensity level. So from this image till this image you have so many differences. Okay, so intensity level basically plays a vital role in actually giving you the clarity on the image. So now we'll be seeing pixel neighborhood. Okay, how the pixels are related with their neighbor pixels. So that is called pixel neighborhood. So in pixel neighborhood, we basically we say that in a digital image, each pixel is surrounded by other pixels. These surrounding pixels from the neighborhood of the pixels, you already know that image can be converted in the form of a matrix, where two possibilities are there. Each pixel has a value based on their location, and each pixel has the intensity, that based on intensity and based on location. So those two values you get. Okay, so here if there is a pixel, you can see that this is a group of pixel. So where if the if we move toward the x-axis, the value increases by x. If we move toward the y-axis, the value increases by y. Okay, so if there is a value x, then if you move towards left, it is x minus 1. If you move towards right, it's x plus 1. Here if we have y, if we move towards y, the value is y plus 1, and if when we move towards down, it is y minus 1. Okay, so this will be x plus 1 y, and this will be x minus 1 y. This will be x comma y plus 1, and this is x comma y minus 1. So this is very clear, I think, to you. It's there is nothing special here. So this is just the arrangement. So most of the pixels are arranged like this only. So generally it's like 0 comma 0 here, then this will be your 1 comma 0. Okay, then this will be minus 1 comma 0, like that. So those values generally we represent this type of pixel by with the help of 4 neighborhood or 8 neighborhood or other m also we have. Okay, so let's see 4 connected neighborhood. A pixel is connected only to its top, bottom, left and right, like this. So if a pixel is connected from the top, bottom, left and right, then they are actually connected in a 4 neighborhood connection, that is also called n4 of p. Okay, so you can see here the diagonal neighborhood includes pixels that touch the reference pixels only at the corners. Okay, so it will be just touching it on the corners only. Okay, you can see like this. Okay, so this pixel is connected here, here, here and here. So these are basically not the part of 4 neighborhood. Okay, so like this the pixel will be connected. So the central pixel has the relationship with other pixel as that is called as diagonal neighborhood. Okay, then we have 8 neighborhood, the combination of both, you can say 4 neighborhood and we have diagonal neighborhood. So both are connected together in 8 neighborhood. Okay, so like this, so all will be connected here. Pixel adjacency is very much dependent on your neighborhoods. So again, the same way we have 4 adjacency, we have 8 adjacency and we also have M adjacency. So 4 adjacency is also called, you can see that if we are looking for element 1, so this, for example, this matrix name is Q and 1 is the element of this Q. So we want to identify. So for example, we are identifying for this one, this blue color one. You can see that this is connected with the top one. This one pixel and this pixel is connected with what relationship? They are connected with on the top, left, right or down. Then in that case, that is called 4 adjacency. So these two pixels, you can say, are connected in 4 adjacency. So this connection is this is called actually 4 adjacency. Okay, same goes with 8 adjacency. If we are considering the same for these two ones, so you can see that this central one is connected with other two ones of the pixel in is actually connected in 8 adjacency. Okay, then M adjacency is little confusing. So what basically it does is 4 adjacency and 8 adjacencies are very clear. Okay, so whatever pixel comes in these corners, those are 8 adjacencies and these are 4 adjacencies. But there is sometimes the confusion, the paradox. So what is the paradox? Let's see. So you can see that these 1 and 1 are connected with 4 adjacency. This 1 and 1 are connected with 8 adjacency, but there is a problem. What is the problem? Problem is with this one. Okay, whether actually this image, I mean this one and this one are connected in two ways, from this 4 adjacency and also this 8 adjacency. So that only I have mentioned here. So you can see that this one and this one can also be connected in 8 adjacency and through this one in 4 adjacency. So which one I have to consider? If this type of confusion comes, if I say from this 1 to 1 you have to move, so which path you will take? You will take whether this path or you will take this path. Okay, so in that case what happens? We have always to take the 4 adjacency. Okay, in this you should take 4 adjacencies only. Okay, and then your path will be this one, from here to here. This path only you have to consider. Coming to connectivity and region boundary. Connectivity basically describes how pixels are related to each other based on their position and values, usually intensity or color. Okay, so let's see. Consider this is a pixel. Okay, in this we have types of connectivity. You can say 4 connectivity, same like 4 adjacency. You have that will be connected on the top, bottom, left and right. We have 8 adjacency, the same way 4 connectivity, in that they will be connected through corners. And we have n connectivity when the connections are actually multiple connections are possible. You can see that in the case of this one. So how it can be connected? If we have to move, we can move like this or we can also move like this. Okay, so this is the confusion. Okay, confusion is basically due to this, because of this path. Okay, So like this we can connect, or like this we can connect. So in that case we have always to consider only four four connectivity. Okay, so if I say we have to move from this point to this point, we have to move like this, like this, like this, not like this. So in the case you have always to consider four connectivity. Okay, so this is four connectivity, this is eight connectivity, and this is m connectivity. Same like 4 adjacency, 8 adjacency, and m adjacency. Now comes the regions. So what are the regions? Okay, so let's see. So definition of a region is a group of connected pixels that have similar intensity or color and same connectivity rule, 4 to 8 connectivity, 4 or 8, whatever you want, you can take it. For example, this is the region of pixels. Okay, and this is also the region of pixels. Okay, and either they are connected by 4 connectivity or by 8 connectivity, any one thing, that is fine. In that case, what happens, they should be connected, this region and this region, separate regions should be connected together. In that case, these regions are connected, considered connected. But here, if there would be like 0 0 and 0, no connections, there are no similar pixels. In that case, those regions are considered disjoint. So this is region 1, this is region 2. Why these region 1 and 2 are considered joint? Because there are two pixels, they share this your 4 connectivity. Okay, or 8 connectivity also is fine. Then in the case if they are not showing this type of connections, then that is called as disjoint regions. Okay, for example, this you can see that this is the leaf, this is the coin. After they are not connected, they are two different regions, they don't have any sharing. Okay, there is no sharing color of pixels, so because of that they are the disjoint, you can say that regions. Then we have region boundary. Region boundary is a very important thing, because that is always considered in many practical aspects. Like for example, we have to do tumor identification. Where is the boundary of the tumor? So those things we have to do, and many algorithms are based on this one, like Canny, Sobel, Privet, like that. Many are there. That we'll be studying in the next sessions. So the boundary of a region is a set of pixels that separate the region from the boundaries. Okay, a boundary pixels belong to the region and has at least one neighboring pixel outside the region. So what it basically says is, if there is a region 1, 2, 3, 4, they are connected or not connected, but generally they should be connected. Okay, so those are the connected regions. Okay, then this boundary should have at least one pixel that belongs to region. There should be similar one. Okay, the boundary pixel belongs to the region and has at least one pixel, one neighboring pixel outside the region. Okay, so from outside the region you can see that one pixel is there. So after that, whatever is coming, that is actually not, b and 0 are not same. Okay, so I'll show you a practical one. You can see this leaf, these corners are the boundary, because in these corners, you can see the corners. After this corner, whatever is there, those are not actually similar to this pixel. Okay, so that's why this is considered as a boundary. Okay, so this was all about today's class. Thank you very much.